so yeah, I'm Kamal, and I work at a place called Heap. It's a user analytics company. And I'm here today to talk to you about having a staging environment for every pull request, but more than that, specifically about how to use Kubernetes to build a system. So here at KubeCon, I imagine a lot of us are very interested in running different kinds of things on top of Kubernetes. Run everything on top of Kubernetes, right? So like we want to run our storage on Kubernetes. There's a talk right now about Rook, which is some Ceph Kubernetes thing, and then you have block stores and file systems. And there's Linkerd and bringing more things so that you can run your externally facing websites, getting their ingress all in the magical Kubernetes universe. And there's all this service mesh talk. And then so if we're not talking about running things on Kubernetes, we're then instead talking about making things run more smoothly on Kubernetes. So this kind of thing encompasses metrics and logging and tracing and monitoring. We want all of our magical Kubernetes stuff to be as magical as possible. And when it's not magical, we want to be woken up and told about it really quickly so we can go back to making it magical again. But the way I want to frame Kubernetes in this talk a little bit is to switch from being something that you run software on and that you spend a lot of effort making it possible to run software on smoothly to being something that you actually build something on. And I'll go into a little bit as we go through the talk on what I mean by this. But the really key thing I want to give you here is that a little bit of knowledge about how Kubernetes works, how the underpinnings are put together, can go a really long way to building something really cool with relatively little effort. Just to frame this, I said I work at Heap. I started there in November, and shortly after starting, I saw a proposal go by for building a system where we can easily see what the app looks like based on a pull request. So we don't have to like deploy to some staging environment or like trust the developers, like say that, you know, hey, it looks great, trust me on my like local Docker stuff, it's cool. We're like, well, it'd be nice if we could actually have a URL that we can give to people to poke around and see what changed. So someone proposed this, and it had kind of a, let's do this, I don't know how feeling to it. There were a lot of unknowns. And so some of those unknowns were like, how are we gonna handle like having 6 of these different environments running at once? How are the ports not gonna step on top of each other? How are we gonna be able to look at logs for all of these things? Like they're running somewhere. Like I think the one idea was like, we already have Docker Compose set up. Let's run it in Elastic Container Service, which takes Docker Compose config. How do we make sure we're not just leaving a bunch of stuff running and wasting our money in EC2? And then how do we expose these staging deploys so we can see them, so we can pass them to your teammate, to someone on customer success who wants to see what's going on with the change that you're making. And well, Kubernetes has like reasonably good answers to all of these, right? How do we have ports not step on each other? How do we have containers not step on each other's toes with the ports? Well, there's the whole networking model. IP per container, you use the ports you want to use. You don't have to have some kind of complicated dance. Logging at a very basic level, you can get it from the command line, kubectl logs. You can get it from the built-in UI. This doesn't require any setup. And then if you want to be complicated, there's probably like 5 other talks right now about how to go on, do more clever stuff with logs. Tearing down, kubectl delete -l, delete everything with a given label. It's all gone, blown away. No worry that you're leaving stuff running around. And how to get it so that you can pass that URL to someone. Well, the ingress stuff is perfect for this. You create an ingress resource, and then that will set it up so that your load balancer in your cloud provider or your Nginx front end has a virtual host or whatever to point back to this exact service. So this is like really cool, and I was like, okay, Kubernetes has got all of these things. So I'd like to say I actually went and built the whole thing. We didn't. We're a small team. Like the whole thing is not necessary for the size of our team yet. It was kind of a proposal that was put out there as this would be something that would be good to have like inside the next year or so as our team gets bigger. But I still threw together a proof of concept. And I'm going to give you a very quick demo. So I think you can try this also. nginx-example.k8s.kamal.cloud. Cloud is a TLD. You can buy it. So this is my super awesome website that I'm running in Kubernetes, and it has a link to its source. It's just it's just straight up, very, very simple example using nginx. And I have an index.html, which is as simple as it can be, except that I set some like garish background colors. This screen is very narrow. Let's make that go away. So I'm just going to go ahead and change something in here and be like, all right, so let's go ahead, create a pull request. And this is this is like a perfect commit message for this. Update index.html. Everyone will know exactly what I'm doing and why. So I'm just going to go ahead and create the pull request. And down here, there's a little, hey, it's got my face on it. That's cool. The little cube review thingy. And this has a link to pr6.kubereview. This takes a little while. The link gets set up before the thing is actually running. But the URL there is pr6.kubereview-kamal-nginx.kamalmarhubi.kubereview.k8s.kamal.cloud. There we go. I just wanted to get the part where it's kamal.cloud. I bought that just for this. I thought it was great. So just give this another few seconds. Oh, there we go. So I created a pull request, and now this is a URL that, if it weren't that long, you could put it into your phone, and you'd be able to see this as well. This isn't like running on my computer. This is in US East, I think, US Central 1. Anyway, it's somewhere, Google Container Engine, somewhere else. And this is publicly on the internet from pull request, and it's there. So demo time, demo god smiled on me. I'm really happy. So there's kind of a lot going on there, right? Maybe we take this for granted, like you click create a pull request, and then Travis does all this stuff. You've set up your integration and all that. Or you're using CircleCI. If you know anyone working at any of these places, there's a lot of stuff going on behind the scenes to make that work. I think it's really cool that, basically, I was able to throw this together in a couple of days. Obviously, it's not robust. You can try and make pull requests. You will probably break it. If you do, please let me know. I know it's broken and not very robust, but I would like to know exactly which ways. But I was able to throw this together in a couple of days. And my level of Go experience is YOLO, I don't know Go. This is all of the Go I've ever written in my life was building this, plus another 100 lines or so. So this is I don't know, a lot of copy-paste, slapping together stuff out of Kubernetes repositories and examples. And it works, and it's cool. And I think that the reason it is able to work and be cool is not that I'm a genius or anything like that. It's just that I was really excited about Kubernetes and read a lot of the documentation and the underpinnings. So I want to talk a little bit about what's going on in here. Yeah, just coming back to that, a little bit of knowledge about how this stuff fits together can go a long way. 2 days to that little thing. So this, I want to talk about how the Kubernetes architecture works and how it actually makes your workloads run. So this is a muffin tray. It's not services or anything. This is a muffin tray. And so you want to be baking muffins. You're probably going to put them in your oven. This is your oven. And your oven has a thermostat. And you dial in 190 Celsius, 375 Fahrenheit. This is probably slightly too hot for muffins, but that's fine because this is a Kubernetes talk. I'm not a baker. But yeah, so you dial in the level you want. You set the desired state on your oven. And then the oven adjusts the heating elements or the gas fire thingies to maintain it. So if it's too hot, it'll turn them off. If it's too cold, it'll turn them on. So there's this control loop. There's a thermometer or bimetallic strip or whatever. There's something that's measuring the temperature, and that's giving feedback back to the heating element. It turns them on if it's too cold. And then that feeds back and increases the temperature. Then it's too hot, and it turns it off. So this control loop is what's underpinning the thermostat. And also, control loops are what underpin basically everything in Kubernetes. The way the kubelet works, the way the scheduler works, the way the ingress controller works. All of these things are built on this same idea of control loops, having a desired state, observations of the real state, and working on bringing them closer to each other. So the kubelet, for example, it's got Docker that it's able to affect, it's able to create containers, and it's also observing from Docker. So if the kubelet knows it's supposed to have 7 containers running, and it only sees 4, then it will create the extra 3. And then it will observe from Docker that, okay, now there are 7 running, and there are supposed to be 7 running, that's good. And then if for some reason you decide to tear down some workload, then all of a sudden now instead of 7 containers on the supposed to be running on that node, they're only supposed to be 6. Well, then the kubelet will see, oh, I've got 7 nodes in Docker, but I'm only supposed to have 6, and it will delete the one that's not supposed to be there. So again, there's a desired state, which is which exact containers are supposed to be running on the node, and there's the real state, which is which containers are actually running in Docker at the moment. And it's just reading from and writing to this state, or effecting change to make it come closer. The ingress controller, which is what I use to get that really long URL, wildcard DNS entries are cool. You can just have really, really long, stupidly nested domains with 1 line of DNS. But what that goes to is Nginx running in my Kubernetes cluster. And when you create a new service and give it an ingress resource, which is telling Kubernetes to expose it so that someone can visit it from outside of the cluster, then what that comes down to is a curly brace block somewhere in an Nginx config file. It's like server host name pr6 dot, that really long host name, and any other path setup that you have, and then it points to the back end, which is the Kubernetes service it's supposed to talk to. So when you create an ingress, that results in adding some config to the Nginx containers, and then when you remove one, then it observes that, oh, the config is out of sync with what I'm expecting. There are not enough. There are too many services being exposed in Nginx, and it will remove them. So that's kind of talking about where the reading and writing in these control loops in Kubernetes is. There's the state, which is either Docker or the Nginx config, and the desired state, which is what's we're actually trying to be running. And in Kubernetes, the desired state, the thing we dial in is what we put in the Kubernetes API server. When we type kubectl create -f, we're throwing in, please put in a deployment resource. And then that's stored in the API server. And that's kind of the source of, that's how we tell Kubernetes what the desired state is. It's how we dial in the temperature. In this case, it's how we run this garish yellow background with blue writing on website. And in order for us to be able to go a step beyond what is just provided by the Kubernetes resources, Kubernetes actually gives us a way to define our own resources. So these are called third-party resources. They're an extension of some kind. But they're a way to say, so resources in Kubernetes, the ones we're familiar with, pod, service, deployment, these are all, the thing that goes after kind in the YAML. We can actually define our own. So for this demo, I defined my own, which is a review deployment resource. And the review deployment is the data that's necessary about the pull request in order to download, build, and run the code as of that pull request. So it just has, to define the resource, we just have to send into Kubernetes this third-party resource definition where we say its name is a review deployment, and it has a description, and like I decided it was like very, very pre-release v0 alpha 0 version. And then now we can do kubectl create with things that are a review deployment type. So now we can actually create our own custom review deployments and submit them into the Kubernetes API server. And they'll have meaning that, so from the API server's point of view, that's just a blob. But we're able to request and modify and watch and do all of the things that the API server makes available with that resource. So to come back to the actual architecture for this very, very simple example, when you click create a pull request, GitHub sends a webhook post to this repo listener, which is just a little service that's just watching for a post request. And that post request has a whole bunch of JSON that includes like the repository, the author, the user, the time, like, but the parts we want are the repo, the pull request number, and the commit ID. And so we can pull those out and then create, this is the review deployment resource. So we pull out the information we want and then post it to the API server, the Kubernetes API server. We have taken the data about the pull request and created a review deployment and stuck that into the cluster. And so the parts, the different resources that we're like writing and creating within Kubernetes for this are, there's this review deployment, our custom one. We're going to need to build and push at that commit. So there's going to be a pod that's just launched into the cluster. And then after it's been built and pushed, there's another pod to run it. And then there's some services and ingresses. And I'm not going to go into like how these things are written. It's just basically template substitution. Like I defined what I wanted. You know, I have a 5-line bash script that runs a Docker build and pushes it somewhere. And just substitute in the argument of like the commit ID and the source to get it from and so on. And then the actual part that's interesting, I think, is just as there was there's the kubelet that's managing what's running on a particular node, and there's the ingress controller that's managing which what endpoints are available to reach into to connect into the cluster from outside. I created a review deployment controller, and what it does is it watches for any new review deployment that's put into the that's put in with like create, and when it sees a new one, it will create that build pod, like submit the build job into Kubernetes, which is just literally a bash script that is like download the source and run Docker build and push to a registry. And then once it'll wait for that to complete, and once it's completed, it will then submit another pod, which is please run that image that we just built, and then that'll be running. And then it will add the 2 extra resources to actually make it available outside. And so I have glossed over kind of quite a bit of like how this is built because frankly, it's a lot of copy paste. I'll share the source. It's really messy, but it's not conceptually difficult. Conceptually, it's a control loop. If you can write a loop that is basically looking at some state and then turning on and off the heater, or creating or deleting a pod, then you could also write the Kubernetes controller. Like, it's not drastically different from a tiny little, I don't know if, I once tried to write a thermostat for a sous vide cooking thingy. And it's like, it's not a lot of code. It's like, 20 lines of C or whatever. It's like, read the thermometer, turn on the heating element, turn off the heating element. Here it's listen for new things from Kubernetes, create things, delete things. It's just as straightforward. And conceptually, it's like all that's there. I will say don't write a thermostat. Like, these things could burn your house down. At the very least, if you do write one and you do burn your house down, I didn't tell you to do it. I told you not to do it. It says so. So another thing I want to highlight is this idea of like being able to create a deployment that's reachable from the outside internet based on a pull request. This could easily have been done since the very beginning of Kubernetes. It's like not using anything fancy. It just requires knowing a little bit about how Kubernetes works under the hood and wanting to exploit that and like use that to build something. So, you know, I just want to like say again, like I'm not smart for coming up with this. I just read some documentation. It's a pretty straightforward and simple thing. And I really, really want like other people to think about the kinds of things that you can do with this. And like, remember that Kubernetes is a platform. It's a platform that you can build on, not just run on. But I really want you to think about it this way because a little bit of knowledge can go a long way. And I'm really, really excited to see what other people come up with because you know, I came up with this. That's not that great, but this platform is really powerful. I don't have to have a Postgres or anything to store the state for all of these things. It's all managed by Kubernetes for me. And I really hope that you'll think about different things that you can do by taking this like really complex engine that has a kind of like relatively nice interface that is Kubernetes and come up with other cool things that are built on top of that. So yeah, thank you very much for listening. Oh. Huh. Yeah, I think there's definitely time for questions, if anyone has any. Yes.
You mentioned you had a listener to listen to the GitHub books. Is that like a data service from a cluster?
Okay, yeah, the question is about there's the listener, so in this little diagram here, a listener that's running in the, and listening for the webhooks from GitHub, and whether that's a microservice running in the cluster, and the answer is yes. It's like 50 lines of Go. It's a HTTP server that's listening for a post, and when it gets one, it pulls out the data at once and plugs it into a Kubernetes request and posts it to the cluster. Yeah. Yeah.
How about updates to PR? If you update PR, push another commit, will it see the change on this?
What I wrote didn't, but there's no reason that that would be an extension. Like in 2 days I didn't get there. Okay. In 4 days I probably would have gotten there. Like that's kind of, you know, it's not. So just to repeat the question is, what would happen when you update the PR? Because you know, like frankly, those.
It's a different event.
It's
not a PR anymore. It's a commit.
So, but you actually, so yeah, this kind of would, you know, that would need you to be looking at the GitHub documentation, but actually they would send you the same event with a different state, I think. So it would look the same, but with some differences, and you'd be able to do the same thing. Yeah. So I actually translated the YAML into, the question is how I am templating in order to send things into Kubernetes. I actually translated the YAML into Go literal structure, like structures as a literal, because I was doing this in Go, and then just defined the values in there. I didn't use a templating engine. I was going to, but I ended up finding that easier. Yeah, here and then there.
What is the reason to use this third-party resource? You can probably do that just in the deployment as well. What are the benefits of the third-party resource when you could not do the deployment, or was it just how things work?
So the question is why create a third-party resource review deployment to handle this instead of just using one of the built-in things? You could probably do this by storing a lot of metadata in either annotations or in labels. I just found it like conceptually easier for me to think of this as a distinct entity, the review deployment, and then it has a few properties. Like its properties are the repo, the SHA, the pull request number. I think that's it. And those are then like top level properties for that resource instead of being like some kind of bag of labels or annotation metadata somewhere on another resource. I thought it was like easier for me.
So you keep that to keep the state of which repositories you want to subscribe to or handle or?
So in this case, it's not about the repositories, but about that particular pull request. I keep the state of what's going on for that pull request, which is, have we built it yet? What was the image what was the name for the image we created out of it, and stuff like that. Yeah. There's a question further back somewhere. Maybe oh yeah.
How is it retrieve the DNS record?
I'm sorry?
DNS record. How is it retrieved?
I can't hear. Oh, okay. So yeah, the question is about how the thing gets exposed to the internet. Like, how is the DNS record created? So actually, let's see if I can do this. Dig. May or may not work. Anyway, there's a wildcard record for one of the subdomains on this, maybe the whole kamal.cloud. And then when you make an HTTP request, the host header includes what you're actually trying to do, and that's what's being like used by Nginx. I'm kind of cheating. But it's like what any shared host does. I'm not cheating more than like DreamHost or anyone else. Yeah. Sorry? Yeah. There is a version that's on my GitHub slash under Kube Review. I'll put it online, and I just need to update it. It's not all there, but remember, YOLO, I don't know Go. Disclaimer, no warranty. Yeah. Yes. Sorry?
The more complex application with several Git repositories, is it possible to deploy several containers or each?
Yeah, so if it's more complex than one Nginx container that has one HTML file, like a real application, would it be possible? There, I haven't figured out what my answer would be, but like however you orchestrate that at the moment, like possibly, like I think the apps resource is a way to handle multiple workloads or something. Or you could just have, like instead of a template for one pod, a template for many pods and kind of plug things in yourself. It would be ideally it would be something generic, but an easy way would be to like encode your application as a bunch of templates and then create the different resources for that. But yeah, for this to actually be of any use to anyone, really, it's probably going to have to be able to handle multiple containers, because most like reasonable applications are at least going to have a data store of some kind. Yeah. Any other questions? Okay. Well, yeah. Thanks again. I hope to see you around the conference.